Okay, so in the second video we're going to look at, in the last video we looked at first of all the different types of energy, and hopefully you've read the pages in the book and you're fairly happy with that. But in this video we're going to look at energy transfers. So in your copy make sure you do a subheading energy transfers. There's a really important law in physics and in science, and it's called the law of conservation of energy. And you definitely want to make a note of this one because this is one that you need to learn. And what the law of conservation of energy says, that energy can not be created or destroyed it can only change from one form to another. Now I'll explain what that means in a minute, but what you can do is, if you want, you can pause the video and then you can make sure you take that down in your copy and put a big square or bubble around it and say must learn, okay, or a star beside it. So what does it actually mean? Well, we know that there's lots of different types of energy, okay, but what energy can do is energy can change from one form to another. So let's just imagine we have a light bulb. Now don't worry if you can't draw as good as me, I know my drawings are excellent. So here we have a light bulb. Well, what type of energy goes into a light bulb? The answer is electric energy goes in. What does that light bulb do to that energy? Well, it changes it. So electric energy comes in, but that light bulb changes that electric energy into light energy. Do light bulbs change electric energy into anything else? Yeah, they change it into heat energy. So what we have here is we have energy is changing from electric energy into light and into heat. And what the law of conservation of energy says is that it cannot be destroyed. So that energy can only change from one form to another. You can't get rid of it. And what that means is, let's say we put in 100 units of electrical energy. Now the units for energy are called joules. So we can write 100J, and J stands for joules. And because energy cannot be destroyed, if 100 joules goes into this light bulb, well then 100 joules must come out. Now the way it comes out can vary. So for example, light might be 80 joules, but if light is 80 joules, then heat must be 20 joules. Either way, no matter what numbers the two of these are, they must add up to 100 joules. So if 100 joules goes in, 100 joules comes out. And we can do lots and lots of different examples of these. Another example might be a television. What type of energy goes into a television? Again, it's electric energy. What type of energy comes out? Well, television definitely gives out sound. It gives out light, the screen lights up. And if you ever feel the back of your television when it's on, it gives out heat as well. So again, energy is being transferred here, but energy cannot be destroyed. So if again I put in 100 joules of electric energy, and let's say 20 joules came out as sound, 40 joules came out as light, we could figure out how many joules came out as heat, because if 100 goes in, 100 must come out. So what number could we put here to make it add up to 100? Another 40 joules. And there's loads of examples, but I'll do one more. What about you? What about a person? Now, here's my drawing for a person. Where do we get our energy from? Well, we get our energy from food, and food is stored chemical energy. So we eat that food, and in our body a chemical process or chemical reactions happen, and we change that energy from chemical energy into different types of energy. For example, we have a body temperature of 37 degrees Celsius, so we give off heat. We walk around, so if we're walking, we're moving. What type of energy do things have when they're moving? Kinetic energy. You could say we talk, so we give out sound energy. So lots of different energy transfers happening here as well. So now what I'd like you to do is I'd like you to try worksheet number 2, where you try and practice different energy transfers. And what I'll do is I'll put up the answers to that worksheet on Teams later today or tomorrow.